Right, so the answers for the butane calculations. So remembering, if you're wondering about the working, all you have to do is go back over the previous slides and use butane instead of ethanol in the calculations. So that's all I've done. So here are the actual answers. So I'm assuming the delta HC from the data book, -2880. As I've said before, there's a bit of a problem with that because normally that would refer to liquid water. So we're sort of playing it a bit fast and loose with the truth here, but that's what we should be looking for. If you balanced your butane equation with a 2 in front of the butane, then the value should be doubled. It should be 5,000 and something or other. Okay, so just watch out for that. Try to balance it with a 1 in front. Makes your life much easier. So then when I've gone through all the calculations for part 1, I've got 49.7 megajoules. For part 2, oh, sorry, that's actually 2. Lovely old Word or PowerPoint started renumbering. Apologies for that. So the third one, 1.71 by 10 to the 3 litres. The fourth one, 34.4 litres. This was assuming at SLC. I didn't write it in there, but that's what we'd been assuming earlier. And similarly, the final one, that was at 500 Kelvin and 1 atmosphere pressure. So that's 128 litres. So I'm pretty sure that I've got that right. I know I haven't showed my working, but I didn't want to take up another 5 slides. So I think you'll be able to work through this okay. Right, now, past exam questions are something that we really need to be aware of from the beginning of the year. So this is an exam question from the Northern Hemisphere timetable. So there are some subjects that have exams at mid-year for schools in the Northern Hemisphere, and chemistry is one of them. I'm pretty sure there's maths methods as well, and physics. So this gives you extra exams to be able to practice on, which is wonderful. These are all on the VCAA website, so you can use those as you wish. The interesting thing is they're not used in chemistry checkpoints. So these give you extra questions that don't come up in checkpoints. So this one was the 2019 exam, and it was talking about different types of fuels being used in vehicles with combustion engines. Yep, that's what we're talking about. Liquefied petroleum gas is made up mainly of propane. So the first thing they're asking for is a balanced thermochemical equation for complete combustion of propane in air at standard laboratory conditions. So notice there's a very generous 3 marks there. Now, I've got the answer following this slide, but I would bet my bottom dollar that the reason why there's 3 marks is 1 for the balanced equation, 1 for including the delta H from the data book, and the final one for recognizing that at standard conditions, water is a liquid. So let's just flip forward to confirm this. And there's our solution. Bingo. So states, as in the water being a liquid, the enthalpy from the data book, and the correct formulas and the correct stoichiometry. So be very wary of a balanced equation that's got so many marks. There's no way that just a balanced equation without a delta H and without state symbols is ever going to get anything more than 1 mark. Right, part B. How much energy in kilojoules would be produced from the complete combustion of 290 grams at SLC? So this one is just 1 mark. So we've got the ratio needed. We need to change the grams to moles, and then we need to work the ratio with the energy in kilojoules. So once again, when we look at the answer here, so, that's right, they've used, I keep forgetting about this, they've used the value in the data book that gives you kilojoules per gram. So you don't even have to change to mole. If you did change to mole, you wouldn't be wrong, but I guess maybe there was a hint there with the 1 mark. So we just multiply kilojoules per gram times the grams. Now see, you can see that from the unit. So energy units are kilojoules. And if we've got the units of kilojoules per gram and we multiply it by gram, the grams are going to cancel out and we've got our answer in kilojoules. So that's a way to know that you've used the right formula. So that came out to 3 significant figures. Now, an interesting scenario here, if you didn't give 3 significant figures, you got 0. So while we say that there is only 1 mark in the paper that will require the right number of significant figures, it sometimes will be the difference between 1 and 0 for a question. Right, going back to the second part of this question. Ooh, where is it? Bang. There. So of the part 3, volume of air, which is 21% oxygen by volume, that would be required to fully combust 68.5 grams. Now, there's 3 marks here because only 21% of the air is oxygen. So you might like to try this before you look at the example, before you look at the answer. So I'll leave you to try that one rather than me jumping to the answer and showing you what's what. You can always stop the video if you need to. Now then, they gave you a question about biodiesel. Now, remembering that we have learnt about biodiesel, this is quite handy. It's telling you about biodiesel being from a reaction between an alcohol and a triglyceride. The fatty acids, now it's suggesting that there were 3 fatty acids here, lauric acid, oleic acid, and linoleic acid. Now, they claim to have made biodiesel using the butanol. Now, remember I told you the other day that certainly by the method that we're going to use in the lab, we can't make butanol work. But hey, you know, we are not expert scientists. We're just working in a laboratory at Year 12 standards. So maybe expert scientists can do it with butanol. So we've got the 3 types of biodiesels. So we've got methanol with lauric acid, ethanol with lauric acid, and butanol with lauric acid. When you see a table like this, do take the time to understand what's in the table. Don't just gloss over it. So part D says, according to the data provided, which combination of alcohol and lauric acid produces a biodiesel that flows the slowest through a fuel line? So these are the viscosities of the 3. So viscosity is resistance to flow. So the larger the viscosity, the larger the resistance to flow. So it looks to me as though the largest value there is the butanol. And then 1 mark for that. So see, that's a fairly easy 1 mark. And then it just requires you to know the definition of viscosity. And then finally, oleic acid and linoleic acid contain the same number of carbon atoms. The viscosities of the esters of linoleic acid are considerably lower than the viscosities of the corresponding esters. Now, you could argue that we haven't done enough yet with fatty acids to really be able to answer this question. By November, you would be able to do this without being worried. So if you're looking at this and thinking, how am I meant to know this? There is a table of fatty acids in your data book. It's quite far back. It's table, where is it? Maybe it's not far back. It's table, there it is, table 9 on page 7. And when they give you the formula of the 3 fatty acids, they actually give you the semi-structural formula, which shows you which ones have double bonds. And that is the answer to this dilemma. Linoleic acid has 2 double bonds in its structure. You'll see that there is a double bond in a bracketed section of the semi-structural formula, and there's a 2 after the brackets. So it's got 2 double bonds. And something we learn really in Unit 4 is that double bonds reduce the ability for intermolecular forces. They make the intermolecular forces weaker. So you've got weaker intermolecular forces between the linoleic acid molecules, and so their viscosity is lower. They flow more easily because they've got weaker intermolecular forces. So if we go ahead to the answers now, so there was the answer for 1C. So hopefully you stopped the video and you tried 1C for yourself, and you'll see that the number of mole of oxygen is worked out from the ratio. So you don't work it out from the air, you work it out from the ratio, and so we get a volume of 193 litres of oxygen, and it's 21% of the total volume of the air. So if you say the volume of the air is X, 0.21 of the air volume of X is the volume of the air. So you take your 193 and you divide it. So I'm just going to go, our volume of our O2 is equal to 0.21 X. And so to solve for X, you divide your volume of the air, 193, by the 0.21. So just talk yourself through that equation when you're trying to do it. And then you get what 2919. Now notice you would have got 2 out of 3 if you just couldn't get that volume of the air right at the end. But our motto this year is that we want all of the marks, not just some of them. So please tackle this ratio. You may find it harder if you're doing further maths. I can talk you through it later when I'm back at school. Right, finally, there's the answers to 1D and 1E. So they are saying it's the butanol. Hang on, what was that about, 1D? Which one? Oh, yeah, oleic acid and butanol. So, not quite sure. Right, so they've sort of talked about the butane 1-ol versus butane 2-ol. This bit here is a little bit excessive because it was identified as butanol. So that's the end of that. If you aren't told whether it's butane 1-ol or 2-ol, you can't say. So yeah, they're just making a point there. Any other situation, you wouldn't talk about butanol by itself. And this is where we see that the person who writes the question is not the person who writes the answers. And I think the person who wrote the answers here was feeling a bit annoyed with the question. We get to 1E, and so you've got your double bond idea here, you've got the justification, and you've got the marks allowed for the double bonds and the weaker intermolecular forces. So 2 marks there. And that is the end of section 3. So you've got main points to write down, you've got questions to do, you've got Ed Rollo to watch if necessary, chapter review questions, and checkpoints questions. The study guide is on the portal, and you hopefully have been referring to the portal because otherwise you wouldn't have found this video. So by now, hopefully you're in lesson 3 for the week. If you're earlier in the week, well then you've got all these questions to do in the rest of your lessons. So I'll see you after your conference. I hope it all goes well.